I was poking around in the attic the other day and I came across this Predicta chassis, and I've got some time on my hands, with being the Christmas holiday break. I've got a few days off of work and the weather's miserable, so I thought, what the heck, why don't I get this recapped? Now, I've got 3 tandem sets and parts of a 4th. This one is the first one I got. This is from the set that has the cable that was clipped off of the head unit. Now, all the parts are interchangeable, so really this chassis could go into any cabinet, and I could use any CRT head with any of the Predictas, so I'm not going to deal with replacing that cable right now. If you recall, the cable was cut off, thrown away. I got it at a vintage resale shop. Since then, somebody found me a cable, complete from the connector end all the way up into the bits that go up inside of the CRT unit. But that is going to be a major project to remove the old cutoff cable and to reattach that the salvage cable. So for now, I'm just going to focus on getting this working. The cabinet's in pretty decent shape too. It actually has a faux mahogany finish. So I have not touched this at all. See, it's still quite dirty, in fact. I believe it's all original. I don't think it was ever serviced. Take a look underneath in a sec. Resistor blew apart, which is pretty common in these sets, no doubt. Somebody plugged it in, tried to fire it up, and went pow, and that was that. Horizontal output tube looks a little bit fried as well. And let's see underneath. The other thing that commonly blows out is the thermistor that goes in series with the tubes to provide a soft startup. So I don't know if they exploded simultaneously or if one went then the other, but without either one of them being there, set's not going to work. These are often bad as well. This is the filament dropping resistor. So if you add up all the tube filaments, there just wasn't enough to put it right across 120 volt AC line, so that's what this guy's about. And there's also a tap in here for the light bulb that goes behind the channel selector. Might still be good, you never know, but if not, I can replace it with some new power resistors. So yeah, I don't see any evidence of this ever being worked on, which is pretty cool. Alright, so to complicate this further, I was working on a Predicta Tandem, you may recall. That's a chassis up there. That's the second one I got. That one was working. That one, the former owner had it restored. And then when he was moving from Texas to Chicago, a fire broke out inside the moving truck, and the set didn't catch on fire, but it suffered some damage. Everything on the chassis was covered in kind of a sticky goo, and there was corrosion. So it got wet. I think there's some damage on the cabinet as well. So I started working on that. I went so far as the board. I replaced all the resistor and capacitors and made some replica K networks. However, before I got to finishing that, somebody found me a spare cabinet with a really nice chassis in it. So I decided, forget it, I'm not going to restore that. I'm going to use it for spare parts, because my third blonde tandem set has a damaged connector, so I've already salvaged it out of this set. So I'm going to use that to scavenge parts to restore the 3. So I've already done a bit of work on this board, so I could take this board out and plop this one in. But I think what I'm going to do instead, oh boy, I replaced all the tube sockets on this too, man. I was about to say what I'm going to do instead is take the resistors and capacitors out of this and put them into this board, but Ah, man. I forgot that I replaced the tube sockets. Because these are, the originals were a common point of failure because I didn't use very good quality sockets. Man, I don't know. I'll clean this board off and I'll unwrap all the wires and take a closer look. Boy, that's going to be a tough call. I didn't solder in these networks though. So those could go into either board for sure. So I figure I could heat these leads up and pop these components out pretty easily and put them into the other board. That's not a big deal, but to get these sockets out, well, I do have a lot of desoldering braid on hand, so I suppose it could be done. I just finished unmounting the board. Actually wasn't too bad. I've done a few of these now, kind of got the hang of it. I don't even bother labeling the wires. I took some reference photos, and it's pretty easy to hook them back up, I think. Something else I noticed is that all the tubes are Philcos. And it was pretty darn hard to get them out of some of these sockets. I had to put a screwdriver down in there and kind of pop them out. So I'm thinking these might all be the original tubes, and they've just, none have ever been replaced, and they've just been sitting in these sockets all this time. So I'd mentioned about that I replaced the 9-pin sockets in this board, but because this has seen so little use, or I mean, like the tubes have never been swapped out, I'm inclined to just leave these in there. What happens is if tubes get wiggled around a lot and replaced, pulled in and out, it flexes these little bent over metal pins and they can break. And you see that these replacement ones, the metal's quite a bit thicker. So, I don't know. I'll see if I might still, well, I might have a bunch left. I don't remember how many I ordered. Now, on one hand, I want to keep it all original, but on the other hand, you want to make it reliable, so what do you do? So these are the 7s. Wow, I guess I've only got like one, or a couple 9s, so, should order up some more, because I've got some other Predicta sets I want to work on. Anyways, I'll ponder that. In the meantime, I can start replacing components. So we got a few capacitors here, and when I do these, I replace everything. Well, at least all the resistors and capacitors. It's just too much of a hassle to take these in and out, so I'm not even going to bother testing any resistors. They just all go. And I used kind of oversized resistors. So although these look smaller, these are actually higher wattage than these. These are, I think that's a 1 watt resistor. That's a 2. Wherever there was a 2 watt resistor, I used a 3. Where there's a 1 watt resistor, I used a 2 watt resistor, and so on. All the half watts, though, I left as half watts. And I've heard this mica cap is a known troublemaker, so that will go. The ceramics I'll leave alone. The coils, of course, I'll leave alone. And I'll replace all of these networks. I pulled out all of the tubes, and they're almost all Philcos. Up until these two, they all are. But these two, which came out of the tuner, well, one's unmarked and one's a Hitachi, so at least a couple tubes have been replaced. Now, as for the board, I was comparing these two. I noticed something right away that doesn't match. 3.3 meg, 2.7 meg. A few other are different as well. 15 meg and 16 meg. Not sure these are replacements, but I know that these match the originals that were here, and they also match the service info. So I looked and I looked. What's especially odd is this came out of the cabinet that this chassis was in, but this doesn't match the circuit board. Neither does this little booklet, neither does the Riders, neither does the Beatmans, neither does the Sams. They all match this one. So, I don't know. This says preliminary on it, which makes me think it's early. And also in the Riders, there's only a couple pages on this set because they must have published it like as soon as the set came on the market. So I'm thinking that this has got to be the early version and this is a later version. At least that's the theory I'm going with. Now I looked through my reference photos, so as I've said, I've got 3 sets and parts of a fourth, so I got 4 boards to compare. 2 of them are this, and 2 of them are this. And both, with the 2.7 meg, came out of mahogany cabinets with a faux finish. This came out of a mahogany cabinet with real veneer, and then I have the blonde faux finish, which also matches this. So my point is that I've got to be careful when I work on this. I cannot go off the schematics. I can't copy what I see on this board. I'm going to have to replace the values that I see. So hopefully I can read all of these. I'm pretty confident all the capacitors are going to be the same. Certainly all the ones I can see here match. But I have to be careful with those resistors. Alright, call me crazy, but here's what I ended up doing. I removed all the old components from this board, transplanted all the new components I'd put into this board into here, with the exception of a couple resistors that differed in value between the two. I did remove a couple of the new sockets I'd put in here, but I decided to leave the originals in here. As I said earlier, I'm pretty sure this still had the original tubes that came with the TV in here, so these have seen no stress. They look to be in fine condition. I think it could potentially cause more harm by trying to unsolder and remove the originals and then soldering in replacements than just by leaving them alone. When I put the tubes back in after testing them, I'll just use as little force as possible, and I think it'll be fine for a long time to come. So that just leaves the K networks. I removed all 5 of them, and I had made 3 replicas for this guy, which leaves 2 more. So I got to do this one, and the one that goes in up there, this guy, like that. This is the vertical integrator one. That's one that's kind of a pain to make, and this guy is just a bunch of resistors and capacitors. Nothing too complex. I'll wire it all back in and then move on to replacing the components on the chassis itself. Now, if you're wondering how I clean this off, combination of isopropyl alcohol, some turpentine, some spray 9, and just some elbow grease. Oh, and a whole lot of Q-tips. Amazingly, all those Philco branded tubes test just fine. Even this fried looking horizontal output tube, which makes me wonder even more now why these two are not Philco branded when all the rest appear to be original. I would have thought that something like the audio output or horizontal output or vertical output would burn out long before the tuner tubes would. Alright, so I painted the last of the 2 replica K networks and soldered them in. So, time to remount this board. So, as I said earlier, I did not label any of these wires. I just took some reference photos. So, we'll rely on those to get everything hooked back upright. I'm not going to twist these wires back on like they were original. Instead, what I'll do is cut the wires off shorter and solder them on. So, for example, not sure this is exactly the right terminal, but let's assume it is. I'll just push it back down. like so, and then just tack it in place. That way, if I don't need to take this board out again, or anybody else ever does, you can just heat these up and just pull them off rather than having to untwist them again. Okay, here is the main board reinstalled and rewired and repopulated with tubes. Now, a lot of people complain about working on these and what a pain it is. I actually kind of like it. Aside from dealing with the wires, once you do it a few times, it's no big deal. It's actually pretty easy to work on once you get this board out, versus the other side, which is a point-to-point wiring, which I still need to get to. But before that, I want to tackle this issue, which is the flyback. I could hear chunks of the coating rattling around in the can, and upon closer inspection, yeah, for sure, large chunks of the coating have broken off. Pretty sure this flyback's good, though. In fact, I've yet to find a bad flyback in any Predictas. So what I want to do is recoat it. This is what I've been using lately, is Momentive RTV 133. It's good for something like 20,000 volts per mil, which is way overkill, but it's designed to electrically seal electronics and withstand high voltages. I've been using this for a while, and the tube is starting to harden up, and I've used a bit of it. So I certainly have enough left, but every time I use this and reseal it, the air gets in there and it starts to harden it. So I don't know how much longer I can keep using that tube. I got it over a year ago now, I think. Alright, but hopefully it'll be good enough for right here and now. So I need to get this box off so I can really get down in there and the flyback. It's held in by a few 1/4-inch screws, I think, or maybe just one. And you got to get this anode cap through the hole. I think I might just replace this lead. It's gotten pretty hard and crunchy. It's rather brittle from heat and age. Alright. Nut down here. It's just hinged on the other side. There's a couple prongs. So there is to it. I think these copper fins here are for cooling. Oh yeah, not only is a lot of this broken off, but it's pooled up underneath. Some cardboard spacer fell off too. Here's a closer look at it from the side. So I'm going to just carefully knock all this old coating off. Donut's getting a bit loose on the frame as well. And then down here is where it's, I think it's melted from the heat of the set running and pooled up down here. I'll try to clean that off. I decided to unmount the flyback entirely. That way I can allow the silicone to set up while I continue working on the rest of the chassis without any risk of damaging it. And there's only 3 wires. Oh, I always forget about that darn high voltage loop though. That doesn't look too bad to get out. So there's only 3 wires connecting on the frame. That's easy to get those out. And I pop the cap off of here, and then you got this cap lead. And I thought that was it, but there's that loop that runs around the iron core of the flyback and feeds down through here and into the high voltage socket. But I can undo the 2 wires down here and then get that out. There's one tube I have not looked at yet. Let's see if it's Philco. Yeah, it sure is. Alright, so I'll do the wires underneath first. That'll be the trickiest. Well, there's a bit of metal that sticks up here, so I don't think when I flip this over I'll touch the fly back. There's a bit over there to support it too. So chunks of the old coating falling off the fly back. Alright, so a bit of weight on the tuner and some of the metal support, and then I'm going to put a stick over on this end. Not the most stable setup, let's see. That'll do, that'll do. So, that's what I want to get off. 2 wires, filthy. Resistor down in there too, it's in series with the output. Looks like it's a 4.7K. Seems awfully small, usually they use more like a 470K or a 1 meg. Let's see. Oh, this is 4.7K. Okay. Oh, that guy right there. Alright, so soldering iron. Turn the wattage down because these wires turn. Insulation, those wires tend to start melting when you heat them up. And then we'll use some solder wick. Okay, I got those 2 wires loose. Kind of stiff, but I think I can straighten them out. Get them through the hole in the chassis, not breaking anything. While I'm at it, I'll clean them up too. All that high voltage over the years collects a lot of fine particles. Once I get this out, I'll also give it another test. I know I tested it when I first got this up, but that was a while ago. Alright, so wires come through on this side and go through the other and wrap around and solder on. Tool got clogged up. I was wondering why it wasn't working very well. Ordered a new solder sucker a couple weeks ago, but I don't think it's even shipped yet. With the holidays, things are really backed up, I guess. Been using this one a lot for a couple of years now, and it's pretty well worn out. Stick with the solder wick. Okay, those wires were a little more of a hassle to get out than I expected because underneath the three wires, external wires, they wrapped other wires around them that go to the core of this, which I had to be very, very careful with. And yeah, I could try to do it with this in place. I think that's what I did on the Holiday, but I can do a neater job if I completely unmount it. I think that's it, but it's kind of fused to the chassis from all that goo. Two screws, and then there's a couple tabs that slide into slots in the chassis. And that is it. These are worth a lot of money. I've yet to find a bad one, but obviously there are people out there who have. They rarely show up on eBay. I think I can only think of one in recent memory, and I believe it sold for in the neighborhood of $100. Now, as for testing it, they give resistance readings on the schematics, so let's see. Between the horizontal output and rectifier, we should have 333 ohms. That's between the two caps. That's the big high voltage secondary. Look at that, 334, 333. I've never seen one measure that close what they say in the schematic. Usually they're off by 10% or so. And again, this is the actual Philco service info as opposed to the SAM's. SAM's reverse engineers their service info. So maybe the original manufacturer's is more accurate. Let's see. Between 1 and 3 we should have 5 ohms. I hope these lugs are labeled. Yes, they are. 6.1, close enough. And between 3 and 6 we should have 8. 7, again, close enough for me. And between 6 and what they call D, 9.4, I don't know what D is. Oh, that's the tab for the horizontal output too. Okay. So 6. This cap, in other words. Alright, close enough. So the secondary is dead on. All the primary windings were off by 10% or so, but obviously it's not open. Yeah, there could still be a shorted turn in the secondary, but again, I've yet to find a bad flyback. I'm just going to go with it being good. So, a couple things I want to do. One is clean off some of this goo, all this sticky goo. It's all down underneath too. Use some paint then or acetone, whatever, to dissolve that off. Also notice it's a bit charred here, and corresponding to that, inside the high voltage box, it's really rusty, right opposite that point. So, it's not on the other side though. So it's sort of set in here like this. The side opposite the copper fins, really charred. Maybe that's from heat. Can heat promote rust? I suppose it can. Or maybe the heat caused some of these resins to become airborne, and that attacked the finish on this box, which is probably cadmium. Maybe it's some sort of really cheap chroming process. You can see where the stickers used to be, it's really shiny, but in other areas it's worn off. Pretty crummy on the top too. Same kind of stuff they make tube shields out of, just the cheapest possible metal alloy they get their hands on. You can see now that this high voltage donut's actually crooked. A bit loose too. Probably over the years this got warm and it kind of slid around a little bit. I'm not going to monkey with it too much. So I'm just going to keep flaking this off. It comes off pretty darn easy. In fact, it's almost all off already. Clean the melted goo out from down here. And then start spreading on the RTV. Messy stuff. I carefully picked off as much of the coating as I dare, which got it down to the bare bones except for right around that high voltage lead. This outer donut's loose and I don't want to stress it and snap the other end of this many turns. So I'm going to start putting on the new coating now. After the new coating is set up, I'll worry about cleaning off the goo of the old residue. It's too fragile, don't want to bump into any of these wires and break them off. So I will pop this open and start smearing it around. One thing I discovered last time I used this was if you get some isopropyl alcohol on your finger or a brush or a towel, you can pat into this stuff and it won't stick to it, so you can smooth it out. In the past, I just kind of smeared this around and it would look really ugly, like when you frost a cake, which is fine. But if you use some isopropyl alcohol, and you can smooth it out and make it a little bit nicer job. Right now, I'm doing a rough pass, squeeze some of it out of the tube around the perimeter. I'm taking the back of a spoon, smearing it around. Stuff is very sticky. You have quite a bit of working time though. Easily like an hour before this stuff really starts to set up. So take your time and smooth it all out. Doesn't really matter if you put it on too thick, but make sure you get a decent coating. Now, if you use RTV 133, it's good for something like 20,000 volts per mil, and a mil is 1,000th of an inch. So this thing only puts out around 12 or 15,000 volts total. So as long as I get 1,000th of an inch or more on there, it's insulated. But I also want to give this thing some strength, some stability. So I want to make sure I get a good coating all around it. I think I've smoothed the silicone out as much as I'm going to bother. It should work out just fine, so I'll set this aside to cure up overnight and move back to working on the main chassis. Okay, now let's take a look underneath the chassis at the work that remains. So this is basically all original, as near as I can tell. Here's where a thermistor would be to act as a current inrush limiter on the tube filament when you turn the set on. Blew apart or fell off. I heard that's what happens over time. They get quite toasty when they're running, and eventually I think these solder joints or whatever they were connected just kind of fall off. So, just like on the circuit board, I've got this chassis that I was in the midst of restoring that I'm giving up on, so I will transfer these parts over here. However, there are production differences. I'm still not quite sure which is the newer, which is the older, but I'll show you one difference right here. You have two high voltage disc ceramics and a little tube terminal strip here and a power resistor here. Not over here, just one ceramic cap, no little terminal strip over here, no second capacitor, no power resistor. This guy is for filament dropper in the tube string. Partly it's there to limit to make up for the voltage difference between the tube filaments. When you add them all up, they don't equal 117 volts AC. And there's also a tap for the pilot light. Don't know if that's still good or not. If it is, I'll leave it in for now. Eventually I may do a more modern replacement for that, but I'd like to get this thing going sooner than later. There's another oddity. It's a 2-terminal electrolytic. One common on this side and 2 positive terminals over here. Later revisions, I think that it's somewhat differently. Either that or when I did this one, I just used 2 individual caps and relocated one of them. But I do recall there's a production difference where they went to 2 individual caps. One mounted over here and one mounted over here. Otherwise, just replace the paper caps here and there and check the power resistors, replace them if they're bad. Oh, and there is one hybrid module under here. I think there's just a resistor and a capacitor. Not much in there at all. When I did this set, I replaced it with discrete components. So I may just do the same over here.